Today's lesson will be a continuation of yesterday's factoring lesson. We will continue factoring monomials out of an expression, but this time we are also going to be factoring not only numbers, but also variables. So let's go ahead and get started. So you guys should be on that page on your handout, which has the following statements. So again, when I go ahead and factor out a monomial or a GCF, again, it's going to now include numbers and letters. I will usually break down my problem into parts. So as I go ahead and do that, I first do what we were doing yesterday, which is the first part will be the coefficient or the number. So again, that's a number in front of a letter. And I ask myself, what's the largest number that goes into all the numbers? What can they all divide by? GCF. The second part, which is a new part today, will be we look at the variables. Only if all the terms have a variable. So we cannot factor out a variable unless every single term in the expression has its own variable. And I ask myself, what is the most number of x's that we can take out from all the terms? So do they all have 2 to take out? Do they all have 5 to take out? And so on. Keep in mind, though, that we can only take out what the least number of x's are in any term. So if the smallest amount of x's that we have in a term is 2, we can take out no more than 2 from each term. And as we wrap it up, remember, as you figure out what's going to be taken out numerically and as a variable, we have to see what's left inside in the parentheses, just as we did yesterday. Remember, when we multiply back through, so we will take our answer and multiply it out, then we should get back where we started with. So remember, always write out GCF on the outside, leftovers, or what's left on the inside. So let's go ahead and get into our 5 examples. Again, same idea as yesterday, only difference is today we are going to have variables as well as numbers. So when I break down the variables, I'm going to break them down just like we did with the numbers. So 18, I would break it down as 2 times 9, xx. The reason why I use 2 times 9 and not 6 times 3 is because 2 is a factor of 10 as well. 2 times 5, x. So I'm going to circle my 2's just like I did yesterday with the times symbol. And I also notice that there are x's in common, or the variable x in common, and I can take at most 1 x from each term. So I can take a factor of 2 and a factor of x from each term here of this binomial. So my GCF in this case will be 2x. So that goes on the outside. Remember, the parentheses represent the multiplication sign, and whatever's left over goes on the inside. So 9x positive 5. So just like yesterday, the only difference is we are now factoring variables as well. Same thing for number 2. We're going to ask ourselves what goes into 6 and 30 first. So the number 6 is a factor of both 6 and 30. I just write out my x's. And I ask myself second, what is the most number of x's that I can remove from each term? So like, see, I have the minimum I have is 3 on one side, so that means I can take out 3 from the other side as well. Therefore, my GCF is 6x to the 3rd power, or 6x cubed. I put my times sign to represent the multiplication, and whatever's left over goes on the inside. So 1 minus 5x squared. And just as a side note, you don't actually have to write this part down. If you can skip this part and do it in your head, that's perfectly fine. Just be very careful if you're going to choose to do that. Let's go on to the next example. Negative 12x cubed minus 15x squared. I ask myself first, what's the number that divides into both of these, the GCF part of the numerical section? So I see that they're both negative, so there's definitely going to be a negative integer here. And it's going to be negative 3 times 4, and then x. Then negative 3 times 5x. I take my numerical part of the GCF, which is negative 3, and at most I can remove 1x from each one because that's the smallest amount I have on the right side, or the right term. So my GCF is negative 3. Leftovers are 4x squared. And because I took out the negative from that minus 15, I only have a positive 5. Be very careful. That's a very common mistake. So whenever you take out negatives, sign switch. All right, let's move on to number 4. Again, try it out before I go over it. Pause it, and then come back to the video afterwards to check your work. So you've already tried this out, so let's go ahead and see what you got. So the GCF for all 3 of these numbers is 4. Let's break these down with a 4. I can circle my 4s, and at most I can remove one x from each term because the last term only has one variable. So I'm going to circle one x on each one. It doesn't really matter which of the x's you circle. They're all the same, technically. So 4x is my GCF, and then I write down what's left. 6x for the first term, 8x cubed for the second term, and negative 10 for the last term. Let's move on to example number 5. Once again, try it out before I go over it in the video. Go ahead and pause it, try it out. Now that you've tried this out, let's go ahead and see if you got the right answer. GCF should be 4. So here we go. There's a 4 breakdown for each one. Circle my 4s across. And at most, I can remove one x from each of these because the last term only has one variable to take. So my GCF is 4x. Put my parentheses to indicate multiplication. And whatever is left, what's left goes on the inside. So we have 4x cubed plus 2x squared minus 3x. And the last term is a positive 1. And that's pretty much the idea for today's lesson. Very similar to yesterday. The only thing we are now worried about is variables as well as a numerical GCF. So it's a combination. Sometimes you may just have a numerical GCF, and sometimes you just may have a variable as your GCF and not a numerical number. So pretty much that's it. Go ahead and get started with the notes, with the classwork. Good luck.